Hello everyone and welcome back to the channel. As promised, we are diving into a completely new and game-changing technology. In our last video, we built serverless API, but what happens when you have a full-fledged application with multiple dependencies? Today we are going to answer that question by demystifying one of the most important concepts in modern cloud computing, that is orchestration or the containerization. In this video, we will break down what a container is, why it's a must-have skill, and how to get started with the most popular tool in this space, that is Docker. To understand why containers are so powerful, let's start with a problem every developer has faced. That is a famous, but what if, but it is working on my machine. That is, we consider it as a bug. We write code on a local machine, it works perfectly. But as soon as we move it to the test server or a production environment, something breaks. This usually happens because differences in the operating system, a missing library, or an incorrect version of dependency. This leads to inconsistent environments and loss of wasted time trying to debug what went wrong. The best way to understand a container is understand what a container is, it is to think about a real world shipping container. Before these were invented, shipping was a logistical nightmare. Every item was a different size and shape. But once the standardized shipping container was introduced, the entire global logistics industry was revolutionized. A software container does the exact same thing. It's a standardized sealed box that contains everything your application needs to run: the code, the runtime, the system tools, and libraries. This standardized box can be shipped and run anywhere on any server, and it works the exact same way every time. Now, many of you might be familiar with virtual machines and easy to get them confused. The key difference is that a virtual machine or a VM has a full independent operating system running inside it. This makes it heavy and slow to boot up. The containers, on the other hand, are much more efficient. They share the underlying operating system's kernel with other containers on the same host. This makes them incredibly lightweight and allows them to start up in a matter of seconds. It's a much more efficient use of your resources. While the concept of containers has been around for a while, it was Docker that made them easy and accessible for every developer. When people talk about containers, they are almost always talking about the Docker. You can think of Docker as the engine that creates and runs your containers. It provides the tools and the ecosystem to manage the entire life cycle, from building to shipping to running your application. The core of Docker is a file called Docker file. This is a simple text file that contains a set of instructions for how to build your applications into a container image. It's a blueprint or the recipe. Once you build your Docker file, it creates a Docker image. This is a read-only template that contains your application and its dependencies. You can share this image with anyone and they can run it into a container. This is how we get that consistency we talked about earlier. You don't need to deep dive into the commands just yet, but I want to show you how simple it is to get a container running. This single command is all you need. You run it and Docker takes care of everything else. That is Docker run command. This "-p" flag maps a port from your machine to a port inside the container. And my app image is the image we built from our Docker file. With this one command, you can run your application on any machine from a laptop to an AWS server. Alright, enough with the slides. Let's put this theory into the practice. I'm going to switch over to my screen now and we are going to build and run our very first container together. Don't worry, it's simpler than you might think. First, I will show you very basic application and a simple Docker file. That's our recipe. We'll quickly walk through what each line does and from defining the base image to copying our code. Next, we will use the docker build command to turn that Docker file into a usable Docker image. You will see how Docker processes the instructions and packages everything up. Finally, we will use the docker run command we saw on the previous slide. I will explain the port mapping flag again as you type in. And then we will open a browser to see our containerized application running and proving that it's now completely self-contained and portable. All right, enough with the slides. Let's get our hands dirty and see this in actions. I'm going to switch over to my screen now and we are going to build and run our very first container completely from scratch. As you can see, I have a completely empty folder here on my Windows machine. The first thing we need to do is create our applications files. The heart of our app is that is the package.json and app.js files. I will be creating a Node.js application. Let's start with package.json. Perfect. I will create this file and then add this content. I have this content ready. This file defined our project and most importantly the starter script which tells our application how to run. I have the package.json content ready. I will just paste it. Here I will specifying the name, the version description and the startup scripts details in package.json. Now let's create the actual application code in a file called app.js. This is a simple Node.js web server that will listen on port 3000 and respond with hello from inside a container. I have this code ready. I will just copy and paste it here. So basically I'm just creating a HTTP server and inside that I'm specifying the code and header and the returning a response hello from inside a container and then listening the server at a port 8080 3000, sorry. So this application will be running on port 3000. Perfect. So application code is also in place. Now for the key file, that is our Docker file. This is the recipe for building our container image. I will just create a new file called Docker file. And I have the contents ready. I will paste the Docker file contents. Perfect. Let's break down these instructions. So the first line that is from node 18 Alpine sets our foundation. This is the base image. Work dir slash app basically creates a directory for our application inside the container. We then copy our package.json file and run npm install to get our all of our dependencies. Next, we copy the rest of our code. The expose 3000 line documents the port, and finally cmd npm start tells the container to run our app. Perfect. With our files ready, we are ready to build the image. I will open my terminal and the command is docker build. So I'm typing the command now. That is docker build dot hyphen t and then name of my application, my node app. Perfect. So this dot tells the docker to use the current directory and minus t gives our new image a name that is my node app. I will press enter. Oops. Okay. So there is a typo. It's build basically. Okay. As you can see, Docker is running through each step in our Docker file and from downloading the base image to installing our dependency. This is the process of creating that standardized self-contained box. Our image is now built. Now for the final step, that is running the container with docker run command. The command is docker run. Let me type in docker run hyphen p and then we want to run the application on port 8080 but the application's port is 3000 as we specified in the app.js and then we specify the name of our application or the image, not the application but the image. Perfect. So this command creates and starts a new container. Let me press enter. The hyphen peep 8080 3000, as I mentioned, it is very crucial. It maps port 8080 on my local machine to the port 3000 inside the container. Now let's open a browser as the server is now listening at this port. I will just open a web browser. Okay, now I'm in my web browser and let me go to localhost 8080 Perfect. So our application is running from inside the container, completely independent of a machine's environment. This is the magic of containerization. So, in summary, containers gives us a standardized as a way to package our applications and their dependencies, solving the problem of inconsistent environments. They are the incredibly lightweight and efficient compared to the virtual machine. And that's why Docker is a must-have skill for modern development. But this is just the beginning. What if you have dozens or even hundreds of containers? How do you manage them? That is the problem that a technology called Kubernetes solves. In our next video, we will dive into a practical introduction of Kubernetes, showing you how to orchestrate and manage your containerized application at scale. Don't forget to like, subscribe, and hit that notification bell so you don't miss out on what's next. Thank you.